7-segment display. What is 7-segment display? It's a numerical display of 7 LEDs. 1, 2, 3, 4, 5, 6, and 7. They form the display by arranging themselves into the number 8, as you can see here. The two types of common pins are a common anode and a common cathodes. You can tell that they're anodes or cathodes depending on which way they all connect up. In this case, the anodes all have triangles. They all connect up, so that means it's a common anode. The common cathodes you can tell by the rectangles over here, which represent the cathodes. They all connect up, so it's a common cathode. The 7-segment display always has this A to G display form. A, B, C, D, E, F, and G's in the middle, and dot point, or a colon, depending on what type that you're going to be using. We're going to be using types of common cathodes. It's wired up in this specific way, and it has 2 digits and 2 decimal places. So A over here will connect to pin 10. The B will connect up to 9, C will connect up to 1, etc. You can pause the video to write them down, for you're going to need them later on in this video. So pin 0 will be connecting to A, B will be connecting up to pin 1, pin 2 will be connecting up to C, pin 3 will connect up to D, etc. You can see that this digit will connect to this resistor, which will connect to ground. And this is our 7-segment display. To create a 1 shape, you need to turn on B and C by turning on pin 1 and 2. That'll turn on B and C, creating a 1 shape. If you want to do 2, then you need to turn on pins 0, 1, 3, 4, and 6, turning on A, B, G, E, and D. Now, let's create the code. This is the code that we're going to be doing. We have numbers from 0 to 9. Now, you can pause the video in order to see what you need to do to turn on all pins from 0 through 9. Alright, now that you've gotten all the code written down, we're going to have an onStart with a variable called number, and we're going to set that to 0. We're going to have a block called LED enable, and we're going to set it from true to false. Now, why do we set it to false? It's because we're not going to be using the microbit, so turn it off. And plus, if this is still on true, which is the default, it's going to mess up our 7-segment display, as pins share different things on the microbit too. And we're going to create a function called writeNumber with an input of num. So we're going to slot in the number in here, and in the function writeNumber, we're going to have a series of if-else until from 0 to 9. Once you've done that, on button B pressed, if number is less than 9, we're going to change number by 1, clear all LEDs, and it's going to write the next number. We have an else statement over here. It's just going to set the number to 0, and it's going to clear the LEDs and call writeNumber number. In the function clear LEDs, we just set every pin to the default 0. Now, let's check it out in real life. So, in the end, after we've connected all of these up, it should end up looking something like this. Don't worry if it looks a little too messy. It's because of the way that the pins are arranged and how the pins of the 7th segment are arranged. So, since we've done the code, when we click button B, we should see 1 when I click it. And when I click it, it should keep going all the way up to 9. And after this, it should print out a 0. And it works! The next one that we're going to be doing is called TM1637. It's a special IC designed to control up to 6-digit 7-segment LEDs. Advantages of using these modules is that there's 2 wire connections. If you don't include the controlling of electricity flow, which is the ground and the 5 volts. It's a very low price. This one's only $4. And it has an intensity control, which is how bright it will get. And there's already an extension to use in MakeCode. Now, the wiring is very simple. The clock will connect to pin 0, the diode will connect to the pin 1, the ground will connect to the ground, and the VCC will connect to 3 volts. I'll pause for you to be able to set this up in real life. Alright, now time to do the code. So first, we're going to need to go to Advanced and click on Extensions. We can type in TM1637. Click Enter, and you'll see that there's this LED digit display module. Click on that, and now you have TM1637. The ones that we're going to be using today are the CLK, diode, the intensity, and the LED count, the show number, and the dot point. This TM1637 extension already comes in with a variable for us. It's called TM. We're going to stick in this clock diode intensity LED count. The clock, we set it up by going to pin 0, and the diode we're going to connect to pin 1. If you want the intensity to be bright, keep it as such. Otherwise, you can change it lower. LED count is how many LEDs are in there. The TM show number is just what it sounds. It's going to show a number. Let's go 1234. Now, grab a pause, 500 milliseconds, and we're going to put in the dot point at 1, show true. This will mean the first colon will be shown. And then we duplicate this again. Then we put that in there, except this time it's false. So this will cause it to have a cool blinking effect. Now, let's check it out. The wiring and the final product will look like this. I decided to use the alligator clips and normal wires because I didn't want to reuse the board, so I have to destroy it. The black and red represents the ground and the volts. The brown and the yellow are for the clock and diode. Now, I typed in 1234, and you can see that I printed 1234. And if you decide to make the blinking colon, you'll see that the colon will blink. So that is the finished product of the 7-segment display of the TM1637. That's all for today, guys. Bye. Don't forget to hit the like and subscribe button. That way you won't miss out any other videos like this.